Now that I have your attention, let's talk about echolocation. You may be asking yourself, why did this guy just waste 27 seconds of my life? And you wouldn't be wrong in asking that. But I promise you, there was a reason for playing that, other than for getting your attention, of course. You see, while you may have seen that video as a cute dog video with some Zelda music layered over it, I saw it as a way to demonstrate the difference between how we see versus how animals that use echolocation see. Animals that rely heavily on eyesight, such as eagles and other birds of prey, Homo sapiens, and almost all other primate species use eyeballs in the front of their head to perceive the environment around them. It's important to realize, however, that not all animals use eyesight to view their environment. That's where echolocation comes into play. Animals such as bats, dolphins, and whales all come to mind when people think about echolocation, but a common misconception is that all animals that use echolocation cannot see, and this is simply not true. In fact, many animals that use echolocation, such as dolphins and whales, have excellent eyesight but choose to use echolocation to sense their surroundings.
How does echolocation work, and how does it relate to physics? Well, echolocation works as follows. For example, we'll use a bat. A bat is able to navigate through pitch black caves with no trouble at all by using their ears. Bats produce ultrasonic frequencies surpassing 20,000 hertz, which us humans are actually quite fortunate for. You see, humans can only register frequencies up to 20,000 hertz. So, if we were able to hear bats' ultrasonic frequencies, we would surely suffer damage to the eardrums. Back to the main topic. Bats use these high frequency sounds as they travel to sense their surroundings, as well as gather information such as size, range, position, speed, and direction of their prey's flight. Bats use echolocation to see how long it takes them for them to hear their own echo. If they hear it relatively quickly, they know that they're close to a wall, and vice versa. Echolocation is a great tool for bats to access quick and easy hunting in relatively safe cave environments. One main reason why bats use high frequency sounds instead of low ones is due to the sheer amount of information that high frequencies can provide as opposed to low ones. Sure, low frequencies would allow for the sound wave to travel farther, but it would not be sufficient in hunting prey that are adaptable to the narrow and wet caves. Also, bats primarily habitat caves, and caves generally are not open spaces, so producing low frequency sound waves to travel far distances would be pretty pointless, as the sound wave would just bounce off the wall within a few seconds at most. There are just a whole lot of pros of echolocation and not a lot of cons, especially for a predator such as a bat. If you need a visualization of what a bat's echolocation would sound like, think of the sound a submarine makes when it scans the environment. Although these sounds are too high pitched for me or you to hear, scientists have been able to lower the frequency to our range of hearing at around 20,000 hertz. And when I say it sounds similar to a submarine, I mean it. These sounds are so similar because, simply put, submarines and sonar technology are humans' way of using echolocation. Although it took us humans a lot more time to develop this kind of technology. Those bats were way ahead of us, about a million years ahead of us to be exact. But I haven't really talked too much about the whole physics side of echolocation, so let's do that. The main physics behind echolocation, apart from the high frequencies, is the Doppler effect. The Doppler effect I won't go into too much detail on, but in summary, it's responsible for the changes in frequencies when a moving object at high speeds travels away from you or towards you. If it's traveling away from you, the frequency will be lower, and if it's traveling towards you, the frequency will be higher. Bats use their high frequency sounds in conjunction with the Doppler effect to locate and hunt prey. The Doppler effect alerts bats to objects, which would be bugs in this case, and the specific location of the bug. If they are flying away, the bat would notice the lower frequency, and if they are flying towards the bat, it would notice the higher frequency in its echoing sound waves. The information provided by such high frequency sound waves allows for the bats to pinpoint exactly where the bug would be, allowing for one of the most deadly combos known to bug kind. When we take a look at sea creatures that use echolocation, we see a different picture being painted. Although the medium of air and water are vastly different, and the speed of sound in water is much higher than in air, echolocation is still possible and is an excellent way for dolphins and whales to communicate with their own species. Before I explain to you why dolphins and whales use echolocation, let me first ask you a series of questions. 1. Have you ever swam in a body of water? 2. What did it look like underwater? If you're a human being, you probably answered yes to the first question and had varying answers for the second. You see, although us humans have cool ways of seeing underwater, like utilizing goggles, other species are not so lucky. Yes, most sea creatures do have vastly different eyes and are more adaptable to seeing underwater. It's still incredibly difficult to view long distances underwater, and that applies to every animal. The reason why it's so hard to see underwater is because, unlike air, water is dense and absorbs light when it passes through its medium. That's why these demonic fish, such as the anglerfish, exist. When you go to a certain depth underwater, all the light from below the surface has been absorbed, leaving a vast abyss of water and death awaiting you below. But I got off track. Anyways, my point is, it's very hard to see long distances underwater, which is the exact reason why animals like dolphins use echolocation. Whales in particular are known to travel down to the seabed and come back with battle scars from fighting giant squids, which is actually pretty fascinating to me, and is largely thanks to echolocation. As we saw with bats, if you're having vision problems, the easiest evolutionary solution is echolocation. Dolphins and whales also use echolocation to communicate with each other, and mating occurs as a result of this. Echolocation is a scientific marvel, and nature ended up beating us at our own game. Sonar technology has changed the industrial world in large ways, so it's crazy to think that dolphins and bats have been hiding this tech for millions of years. On a side note, what I find so amazing about sound and everything we've learned so far in the sound unit is just how versatile sound can be throughout the world, and echolocation is no exception. As always, thanks for listening and have a great day.